All right, I guess we'll get started because I don't want to hold up the next speaker. We have about a half hour here. So my name's Chris Gertie. I work over at NASA down Johnson Space Center, and I want to preface this with saying that I am neither an expert in VR nor an expert in systems engineering. But the part of the job description at NASA is to jump right in and learn what you got to do to get the job done. So that's what I'm doing here, and I would love feedback. I've already talked to a lot of people about things we could try. The last presentation was awesome as far as an overview of what's out there now, and so that's really going to feed into the possibilities of how NASA can use it. So today I want to start a little bit historically and tell you a little bit about how NASA has been interested in VR for quite a long time, and then get to the practical side of what systems engineering is all about and what it isn't, and then philosophical about what might we be able to do with the technologies that are out here. So the goal for today is data exchange. I really would love your ideas. If you have any questions of me of what NASA is all about and how we plan on using immersive technologies, I'd love to try to answer it, but really the future is wide open. We're going to Mars, and we've planned out little pieces of that so far, but the road to get there is going to be amazing and awesome. So systems engineering at NASA, there's so many different ways to look at it. Depending on who you are, you might see a spacecraft in a lot of different ways. And traditionally, we have this general process that we go through. We have some high-level goals, these level 0 requirements, and then it goes down to some system requirements. So we get really good at writing down shall statements. It shall have this size, and it shall have this much power. And as soon as you cross, does this thing have a laser? Probably not. Is the red thing a laser? Yeah. Awesome. All right. So right about here, things turn from a system of systems design to a actual system design. So you're designing a box. And that's where systems engineering kind of encompasses this whole thing. But really in this design part is traditionally where you've seen a lot of the immersive technologies emerge. So then as you're going back up the V, you start verifying those things and saying, hey, did we meet all these requirements? And is this concept of operation really work? And unfortunately, in the human sense, we often don't get to see our design until everything's all built and put together. And so what happens then when you say, oh, I missed this one thing, or we're not able to do things that we discovered in the last 6 months we really want to do? Well, sorry, you didn't write it down. And that's usually what happens. So there's a lot of ways to look at systems engineering. From a lower level, at each individual part, it's kind of seen as an engine. You get some requirements from above, and you feed some requirements down. But in the essence, you can look at it as a wheel with behaviors. In the essence, you've got to look at your project and say, what kind of systems engineering do I need to do? And where do I need the verifications? Where do I need the design? And how can I break this up so that we can get the task done and get people working, actually designing something? So how does virtual reality fit into that? So virtual reality has really facilitated those complicated situations, those conversations that have to happen before you design something or before you build it. And we've been doing that since the 1990s. These teleoperated robots, TORs, we don't use that acronym anymore. There are plenty of other ones, don't worry. We have VR technologies talked about in this 1991 document about going to Mars. I was surprised by the HD TV. Where yes, good. You got to reach into the mind of Steve Jobs and wonder if that thing was read by him or not. So what that evolved into at NASA, and if you heard Eddie Paddock's talk on Monday, he talks about the virtual reality lab that we have in Building 9 at NASA Johnson Space Center. And that's used for several different things. The most prominent is the crew coming in and training about the specific path that they will take on their spacewalk. Every handrail has a name. Every valve that they're going to approach has a location that they can highlight in this environment. And they'll go through that in the virtual reality lab with some mixed reality components. You can't see it so much here, but they call it Charlotte, is the web of move, different different pieces of hardware. So they'll actually be able to have force feedback with the handrails they're holding, which will be their force that they impart on the handrail stand still, but they will move themselves in the model. Still a little freakishly weird because their inner ear says you're staying still, but it works for the training we need to do, and they can work together. So their team works together on different parts of the spacecraft. And to the outside eye, it looks like this. We don't have a crew member in here, but it's a really high fidelity model. They use that model to do press briefings and to show the crew where they're going to be working. And this model is called DUG. You may have heard it. I'm going to not even start with the acronym because there's... Yeah, but then leads to the story as to why they called it Doug, because the guy's name was Doug that was working on it, so he wanted his name. All right, so Doug has been very useful, and we've even put it on the station in our very first Google Cardboard, which was on a laptop that we had up there already and used foldable plastic instead of cardboard. But it worked, and we got to give them just-in-time training on an upside-down screen so that they could use the SAFER controller. The SAFER is the jetpack that sends them back to wherever they let go of by accident. So this controller is what they pull out of their spacesuit if they were to let go of space station. But it's a complicated process and very limited fuel. So you got one shot at this contingency scenario. So we give them the training as late as possible, along with all the time they're on the ground. But for the space station crew, that could have been 8-9 months ago, or in this guy's case, over a year. So this is Scott Kelly. He had the HoloLens flown up before he came down, and they continue to do experiments on it. And as a crew assistance tool for just-in-time training, for popping up some procedures. What was interesting, and the last talk touched on this, is these norms start getting created. And it used to be you talk to a crew member about electronic assistance tools, and they're like, "Don't get in my way. I got the paper. I'm going to jot some stuff down, and I don't need it to be more complicated." That's still there, but it's evolving since we start introducing these new tools. And frankly, people develop norms in their normal life, and they have an iPhone with a lot of procedures on it for other things. So they bring that into space, and they expect that same kind of assistance. So we predict that as they start using this years down the road, they're going to be expecting this type of thing up there. So we have to figure out how to use it. So I want to transition a little bit to how we used to, or how we still do, our somewhat virtual reality for spaceflight. In absence of an actual moon to practice on, we create a moon on Earth. And we've been doing this since the beginning of the space program. This is a little Mercury capsule that they built up to get this size and shape, just talked about at that boardroom table. But we've done it in a much grander scheme. We've got a NEMO mission that goes on a couple a year that puts a crew in a module the size of a school bus in a hazardous environment, 45 feet underwater, so that they're saturated with nitrogen, they can't come back up. Do all sorts of experiments on other systems engineering projects that are representative enough to get those questions answered that can inform the design in time before it's locked in too much and we can't change it anymore. So there's also terrestrial analogs, and this is on the C9, which is an airplane that does the zero-G flights, the Vomit Comet, which it gives that other. So every piece that we need to try to simulate, we can get a piece of that answer at one of our simulations. So I run a lab at Johnson Space Center called the Hive, the Human Integrated Vehicles and Environments. And so interspersed in this lab are different pieces of components of habitats that we fly. And what we'll do is have customers come in and experiment on their project, whatever it is, an app or a tool or or a theory, and run their test on one of our habitats, and do some human-in-the-loop training with our space and life sciences folks, and get those answers in time to inform their designs. So, so again, where we're doing the work is in the concepts and then kind of validating it before we get down into the detailed design, so we can kind of get ahead of the game and make this better. So when I'm in this lab, I'm thinking, okay, we want to get more customers in. We want to have people answer their questions, but they might not know what all they can do yet. They need to get in here, and they need to be creative with how they build up their test. And I thought, what better way than to bring in Vive, full room VR. Maybe we can take somebody's model and they can email it to me, and we can play around with that even before they step foot in the lab and see if we can meet their needs. So what I did was, and this is where I want to start the conversation. We have some SketchUp models that we threw into the Vive. I threw it into Unity first because it had some physics involved, but the Iris VR package has proven a little bit more useful. If anyone's familiar with that, it's a way to take your SketchUp model, put it on a table, and then zoom right into it and walk around. And with the Vive, you have that 10 by 10 area to really feel like you're in there. So all we had to do was get the headset, workstation, and a little bit of floor space. And what that's enabled right now has been to, let's see if this actually plays. All right. So what this has enabled is, oh, do I actually have to hit the red thing? All right. Upside down there. All right. What this has enabled is there's a conference table where we are. All right. So I'm able to, or whoever's project lead can put on the headset, grab some controllers so they can point at things, and then the model that everybody's baseline that they're working towards right now, they can put in SketchUp and then export it to this Iris VR. And now we can talk about it. So everyone in the conference room is able to see what's on that screen. I'm able to actually be in it and say, okay, listen, these are the ideas we have for the next step in our development. For me in particular, that cylindrical piece down there is a mock-up that we plan on putting down in that high bay. Well, there's a lot of questions. How tall does it need to be? What about the door size? Power, where the power unit's going to be, and is there going to be a desk outside, or is it going to get in the way? All these questions, we're just throwing things up in the air. Say, oh, well, sounds about right. 9 feet, okay. Ceiling, I don't know. We might want to see it from up top, but can we really see it from up top? So those types of questions, and then shown here, okay, I can annotate. Oh, but I don't think I want to download one of this one, so let me just undo. And meanwhile, I'm talking to the folks that are working on the project. That type of interaction saves days of emailing, and somebody, one guy or girl who knows how to sketch this stuff up in the model, it is constantly being asked, oh, could you tweak this for a second? I got to talk at a meeting. And instead of that, you can have all that real time. And I witnessed this with Jake in the back there on a project that is much more mature than our mock-up. We're making a biodigester on site for Engineers Without Borders, and a very detailed model was generated in SketchUp. We started talking about cable routings. You never talk about cable routings until the thing's actually built, and that's usually the last time. Very much too late to think about some serious issues like, is it going to flood in the cable line, or do we need some kind of protection for it? So what I'm doing here is just talking about different things to my team, and seeing if we're going to be able to have people working down below, but also follow along up top in the actual lab, because we're connected and we might have some camera views. Being able to see directly down line of sight to the model is important too. So you'll see in a second, I think I zoom back upstairs and check out the view and see if we have eye-to-eye contact and all that. So I guess I could, at this point, ask if anyone's had a similar experience, wherever you're from, and if you've designed something and have used any of these tools. Have you seen your teams adopt it? Have you noticed any kind of reaction to this type of thing? Is there anything that's missing when you go into VR? Any experiences out there at all with some of this stuff? Yeah. Sure, yeah, that would be great. But there was a question here.
Well, first off, what software are you in that you're annotating live?
That's Iris VR.
That is Iris.
Yeah, and there's.
I also use Iris pretty heavily. I work for
Okay.
But for us, what's been really big with this kind of experience is the client feedback in terms of being able to kind of go through what you said in terms of getting feedback with your team immediately and all the time.
Yeah.
I mean, we almost never get there sometimes on projects where the client isn't fully understanding it, which we talked about earlier, and maybe they're not saying that they aren't because they don't want to give they don't know what's going on or something like that. But I personally just did a project. We didn't even have to take it immersive into VR. We just had to walk through it on the conference room screen. But every meeting turned into just walking through the space, regardless of what phase the project was designed by. As soon as the client saw that, they got it immediately, and it was just like, great, okay, walk over there, let's do this, let's change that, and that 1 hour work session basically covered what we would otherwise do.
Okay, so that saved time rather than interrupt the process with a bunch of tweaks. You're saying?
And,
okay. Because we're very concerned about that too.
Document what they said in the meeting, go back, make the changes that you may or may not understand what they said correctly, then generate a rendering, come back, do the whole process over again. That's all.
Okay.
Right.
Do you feel like they trust you less now because they have access to all that information?
So we were a little trepidatious in the beginning because we're in this world where we can control the rendering as like the master architect and master artist, right? And everything 1 degree outside of what you're showing them doesn't matter. They don't have to know that you're not done figuring that part out yet. But now,
let me look under this table. Yeah.
You just have to be honest with the client, which is better anyway because it helps the process through a project regardless.
Mm-hmm.
Whether you're designing something for a space station or a building, I'm sure it's the same. You don't have everything figured out from day one, and it's all a long process.
Exactly.
Sometimes the expectation of the client doesn't necessarily align with that. And I think this helps in that sense because they take a bit of ownership of the process, and they're involved in it from day one. And as long as you kind of talk them through, listen, this is the working model. We don't have it all figured out yet. We'll get there. We're going to work together to make this happen. Then as long as you have that conversation at the beginning, you set that expectation, it's going to make that.
Yeah, so it encourages an air of transparency, which.
And it kind of builds that client,
trust.
In our case, architect trust.
Yeah.
Because you're letting them into your world.
Exactly. That's great.
Yeah. You'll ever have a collaborative space in Iris VR, or is that possible, where you bring in a section? So you're saying, let's put this here, and he's like, also put this here, where you can see each other.
I bet that that's possible. If anyone else knows, please let me know. But
I think they're not available on their current software, but I'm talking with a lot of these developers. I think it's in their media roadmap. I believe it was them. They already have at least a base level kind of cartoony avatar that they're already setting up and testing. I'm sure they can have those collaborative sessions.
Excellent. Yeah, because that'll facilitate the site to site. If you got 2 different teams working on the same, or they each bring their models and say, okay, how are they going to work together now? Yeah, that'd be huge.
And next thing would be, I wonder if, sorry, I don't want to divert from what you're talking about. Maybe I should ask after, but they can Google SketchUp if it's got this relationship with Iris VR, and instead of just drawing on top of the Google SketchUp, can you interact with that body in Google SketchUp and say, look, we move this here, and then it goes like a live update to it.
Yeah, and that could be done that way, or in Unity, there's more of a physics engine, so you can make objects that are movable, and you could physically pick them up and put them somewhere. It would drop with gravity, and you'd be set. And so there is another aspect of it. It's a good transition to what another part of this. Let's see. I don't know if it's going to give me back, but well, that V that we looked at before. So the testing, the verification, the human in the loop testing becomes super important when that's your validation. If a human can operate within all their constraints and they're not reaching back and injuring their shoulder or something. If we give a little bit of physics to our models and we have a high enough fidelity mixed reality environment, now we can model things that wrap around the hand controllers, or if HTC comes up with a little puck or something that we can attach to anything, then we tell the computer that this is this device. We model it up in cardboard, foam core, or whatever, and now it acts like that. And then when we see it, we can actually operate the thing. We can move it and do a task. So you imagine, okay, 4 blocks, and we got to move these blocks from here to here. Do I have the reach while I'm still in my harness? And so we can actually do those tests with these blocks, see the reach, get all that data, and then feed that back to the human factors folks and say, yeah, we've met our HSIR, the human systems interface requirements. So.
I was going to let you know, I think HTC has open sourced the tracking of sensor technology for the positional markers.
Okay.
Excellent.
Excellent.
They're actually sensors. So independent developers, especially vertical markets like yourself, you can cobble together sensors to put on anything that you want to track in VR.
That's awesome.
So, and it's not very expensive, I don't think. I mean, they're very simple sensors, obviously. So there are a lot of applications for very custom applications like that, where if you need to track extra constructed things in space, physical things in virtual space.
Yeah.
You can attach those and make reference models in Unity or whatever. So.
That's great. This warms my heart.
Frank actually bring up a PPG and then analyze that file and look it up with the.
Nice. Yeah, so you're referring to Frank Delgado? Okay. So that's why we're partnering with all sorts of other groups at NASA, and so there's some specific labs who have a lot of experience in this technology, and so they're diving into it. When you say open source, when you say encourages transparency, this stuff is near and dear to my heart as part of the Open Innovation Program a few years ago, and we tried to encourage ways to open source NASA technology and open up our data so that people could use it for the rest of the world to solve their problems. So it's awesome to see that immersive technologies are following that route. Question?
I'm just curious if the other members of your team who are not wearing the headset and watching the screen, if they find those movements a little bit jarring, because even watching it now, when you do those big heads,
Yep.
that made me feel a little bit ill. And then are you mindful of that and not just...
So that's a great point, and I was thinking nothing about my audience because there actually wasn't. There was just a camera. So, but I should have been thinking of you all, and so I guess that person is going to have to be a savvy presenter in a way that we have presenters that much more savvy than I am just standing here. So exactly. So they'll have to fly in a way that shows the path attractively.
I don't know about Iris, but in Unity you could easily set up a third camera.
Yep.
A stationary camera.
Yeah. Or have someone else fly that camera with a hand controller or something to just look over the whole situation. Yeah.
And I was going to ask about why aren't they a headset that way with design to Iris?
Yeah, not yet. I mean, there is a serious graphics card that's driving all that. So we're pushing the limits of that, but that's only a matter of time. Moore's law. So coming up in the last couple of minutes, are there any final questions? Yeah. So it's just an algorithm on top of their movements that stabilizes it like a camera would or something. Yeah, I bet. Star Citizen. Cool. Okay. Yeah, I'll check that out. Maybe it's an open source plugin I can just throw in there. Awesome. Well, I'm getting the 1 minute sign, so let's wrap it up and let the next speaker set up. But thank you very much for coming out and sharing your ideas.